Hello everyone, in this video we're going to cover some of the topics for exam 2 that are corresponding to trigonometry questions. So first than anything, we're gonna go with true and false questions, and then after that we're gonna go with some multiple choice questions, and we're gonna see why some of these questions have the results that they have. So for example, on the first couple questions, they're asking me the domain of that particular function, and of course also what is the range. So that's going to help us determine if what we have here is true or false. We can double check this in many ways. One of the ways that we can check this is just checking by calculator. You know, if cosine to the minus 1 of a square root of 3 over 2 is equals to pi over 6, if you calculate this with your calculator is equal to this, then it's fine. Another way that you can do that is taking into account under the domain. So for example, we know the cosine to the minus 1 of x is taking x between minus 1 and 1, and it's giving me values y between 0 and pi. Since this value is between 0 and pi, then it's fine. And we can also think of this as cosine of pi over 6 should be equals to square root of 3 over 2, which we can verify here with our special angles. So in this scenario, this is true. We will think the same. We tend to think the same thing about this because if you go ahead and calculate sine of 7 pi over 2 over 4, then you're actually going to get minus the square root of 2 over 2. But in this scenario, this is going to be actually false, because the problem is that 7 pi over 2 is not going to be in the range of sine. So here again, for sine, we have that the domain is going to be between minus 1 and 1, but the range is actually between minus pi half and pi half. So instead of being 7 pi over 4, you should do minus pi over 4. This is the real value that this is going to give me, not the positive. So instead, should be minus pi over 4, which is between the range minus pi over 2 and pi over 2. And so that ends up becoming a false in here. For question number 3, we have that they're asking if the point minus 0.55 comma 0.84 is a point in the unit circle, and then we want to know if cosine is minus 0.55. And in this case, this is true, because for a point in the unit circle, we know that the coordinate x represents the cosine and the y represents the sine. So indeed, these two are going to be equal. Now, question number 4 is asking me if theta is in the first quadrant, and we know that the value of cosine is the square root of 5 over 6, then if the value of sine is the square root of 41 over 6. And in here, is very easy to find out by doing the right triangle. And then we have information about cosine. Cosine is adjacent over hypotenuse. So we don't have the opposite here. But we can find out the opposite by doing opposite square plus the square root of 5 square is hypotenuse square. And so this means that the opposite is the square root of 6 square minus the square root of 5 square, which is going to be square root of 36 minus 5, and that's going to be a square root of 31. So this means that the sine of theta is not going to be 41 over 6, it's going to be square root of 31 over 6. So this ends up being false. Now, question 5 says the equation cosine of x equals 0.4 has two solutions on the interval 0 to 2 pi, and this is true. Notice that we're talking about the interval 0 to 2 pi, so we're covering a full circle. And when we're doing cosine, cosine is the x coordinate in the unit circle. So if we do 0.4, let's say this is 0.4, it's a little bit further, but we're gonna have one solution in the first quadrant, and we're gonna have another solution on the fourth quadrant. So this actually is going to have two solutions. Now let's move on to the multiple choice questions. So for the first question, we have that we want to solve for the angle for the side A and B with this triangle here. We have information on the hypotenuse and we have the information on the angle. So we pretty much can get B by using the sign. You remember B, or opposite over hypotenuse, is the cosine of 35. And A, which is the adjacent, this is adjacent. Adjacent over hypotenuse is the cosine, and opposite over hypotenuse is the sine. And so with this, we have that A is going to be 15 cosine of 35, which is going to be around 12.3, and B is going to be 15 sine of 35, which is going to be around 8.6. And so that's going to give me this answer. Now, question number 2, we have another triangle. We have that a zip line has an inclination of 35 degrees, and a rider average speed of descent is 45 meters per second. So we have a right triangle here, and we have an inclination of, again, 35 degrees. We want to check what is the horizontal distance that the riders do if it takes a trip in 25 seconds. So we know that this distance is being covered 45 meters per second. So this hypotenuse is going to be 45 times 25. Okay. And let's compute that. That's 1,125. Now, since we have the hypotenuse and we have the angle, then we can find out what is the horizontal, which is this. So we can do that with the adjacent. So this distance here is going to be 1,125 times the cosine of 35 degrees. Remember, the adjacent to the angle is going to use the cosine, and we have the hypotenuse, so we can find out the distance with that. So if we actually compute what this is, we're going to find out that this is 921.5. Now, question number 3 says that a person is swimming in the surface of a lake. So we assume that this is the surface of a lake. And we have another triangle here where this is above an incher, and it has a distance d over here to the inchers that is down here. The swimmer swims to the boat that is over here at a speed of 3.5 meters per second, and it takes 36 seconds to reach the boat. So pretty much if I call this L, this L is going to be 3.5 times 36, which multiplying that is 126 meters. Now, I know that the inch cable is being pulled nearly straight at an angle of declination of 40 degrees. So this angle here is 40 degrees. And we want to know how deep is the water below here in the incher. So because this is the opposite to the angle, then we can use a ratio of the sine over 40 over the cosine over 40, which is the tangent. At this height, it doesn't matter to use tangent anymore. You can use it. So d over 126 is equals to the tangent of 40. And so we're going to have that d is 126 and then tangent of 40, which is going to be around 105.7. And so that will be answer A. So remember, especially for the final exam, it doesn't matter anymore. You already know everything, so you can use sine, cosine, tangent, whatever is the tool that you want to use. Now let's go to question 4. Question 4 says, determine all x in radians in the interval 0 to pi half for which sine of 3x is 0.65. So first than anything, we wanna check what value is that going to produce. So if sine of 3x is 0.65, we can get that in the calculator. Like we have that 3x is sine to the minus 1 of 0.65. So with my calculator, I'm gonna get that 3x is actually 0.71. That's what my calculator is giving me. And so x is gonna be 0.71 divided by 3, which is approximately 0.24. And remember that this is in radians. So now this is less than this pi over 2, because pi over 2 is 1.5, right? So this is far from there. But we can take another angle. So we can do, since we got that 3x, it was 0.71. We can also do the second angle being pi minus 0.71. And so this will mean that having 3x being this quantity, well, x is going to be pi minus 0.71 divided by 3, and so that will be 0.81. So this will be my second angle. My first angle will be this one, and my second angle would be this one. And of course, I cannot have more solutions in here than those two, and so from here I know that it gotta be this option. In here, some of the things is that you already know that you're gonna have two solutions, so you're looking for it. So another way of just checking which one is going to be your solution is you can plug some values. You can plug in radians 0.24 in here, verify if it gives you 0.65, and then plug 0.81 and verify that it gives you 0.65. That's another one, another way of achieving the same result. Now, question 5 says, what is the value of theta in degrees? In degrees, notice, in the right triangle below. So in here is one of those scenarios where we have to be very careful to actually get what they're telling us. In this case is in degree. We have the adjacent, the hypotenuse, so we can have a relationship with the cosine, right? So cosine of theta is adjacent over hypotenuse. So theta is going to be cosine to the minus 1 of 11 over 19. Put in my calculator in degrees, then that's going to be 54.6. This is very straightforward. Now again, for question number 6, it tells me give two angles theta in the interval 0 to pi such that sine of theta is 0.72. And so in this scenario, of course, we want to start with theta is sine to the minus 1 of 0.72. And once that you have this value, this is going to be 0.8 radians. So once that you have the first information, you know that it's either A or C. So the second thing that you want to check is, well, where do I have my second information? And since this is a value of sine and sine is positive, it means that the first value is going to be on the first quadrant and the second value is going to be on the second quadrant. So to get my second angle, I just need to do pi minus 0.8. That's gonna represent this angle over here. And so pi minus 0.8, that will be 2.34 radians. And so my answer will be C. Remember that we are in the unit circle, and on the unit circle, sine is y, so that's why I'm taking the height in y. And being 0.72 means that the height is 0.72, and this is getting me this point in the unit circle, this point in the unit circle, so I have theta 1, which is this angle over here, and the second angle, theta 2, is this angle over here. But to find out this angle is very complicated right away. So what we do is we take the entire pi and we subtract this little angle, which is theta 1, and then that's going to give us theta 2. And so that's where we get our second angle. Alright, so hopefully this worked out as a refresher of how to obtain this type of angles. Practicing how to obtain different angles is important. Change here the value of sine between positive and negative, so you can experiment with some values that are in the third and fourth quadrant. Also modify this value to this trigonometric function to be cosine, and so if cosine is positive, you'll have in the first and the fourth quadrant. If cosine is negative, you'll have between the second and the third quadrant. So that's the key. Try to practice that many times.